Hi everyone, my name is Alex. I'm heading our IoT business at Nixu, basically meaning I'm responsible for service development and delivery when it comes to delivering cybersecurity services primarily to product vendors. So if you are an asset owner or you are working in a production facility, most of my time I devote to working and delivering cybersecurity services to secure the devices that you have in your facility. But on the other hand, I also spend quite a big chunk of my time on studying as well as developing or helping to develop services for OT or cybersecurity services for OT environments when we are again talking how to secure your production facilities and your production process. 5 years at Nixu. It's a great time to be working in cybersecurity field since there's so many things happening so fast and they have significant impact to the future of our society. So it's great to be part of this digitalization journey. A couple words about our company. So Nixu is a publicly listed cybersecurity services company. Bit over 50 million in revenue, roughly 400 people employed, and we are focusing purely on cybersecurity services. So we don't do your administration or we don't do basic software development. Everything that we do relates to securing your IT environments, OT environments, or IoT products, and of course digital services. We have been around for a while, so since 1988, and our background is heavily based on telecommunications industry, so telco equipment as well as mobile phones, which were the first IoT devices of that time. When it comes to OT and IoT, they are very much related, as I mentioned, and to give an example of what we do in both areas. So, for example, we have a case study with Swedish Match, which is a global manufacturer of snus, Nuuska, which is a very important aspect of some people's lives. So we are helping them to make sure that their production is resilient against cyber threats. And on the other hand, when it comes to IoT or industrial IoT in terms of components, we have won an innovation prize together with Danfoss on actually producing a innovative security framework to some of their products. So making sure that their products are secure. So this is as much as we talk about our company. Let's move into the topic itself. And we'll start with the buzzwords surrounding a term called Industry 4.0, what it actually is and what it consists of. And I wanted to have this section very brief. I guess everyone who's working in a production facility right now is concerned or is undergoing a transformation or is planning to undergo a digital transformation, which basically means that there will be new highly connected systems mixed with the old systems that most likely have decades of difference in age, and they all need to be interconnected and maybe even communicating with each other somehow. At the same time, the systems become, let's say, they're becoming cyber physical, so their impact, they are connected and they have direct impact on the surrounding physical world. And many times they're also autonomous. So things like load balancing of power grids, things like that. Many times it's done automatically, and this is only growing, let's put it this way. There's also demand-based production that is now moving towards being more autonomous, where based on a bunch of data coming from the outside world, the production facility then optimizes its own process to make sure that the production or manufacturing or production is on par with the demand coming from the global market. Obviously, what it also means is that there's a convergence between IT and OT. So digitalization finally comes closer to the OT side, and there are many. I'd say it's easy to say let's converge IT and OT, but in reality, it's of course a bit different. So you have on one hand, you have systems that don't have 20 years of lifespan. They are easy to patch, and network segmentation is easy. And then you have OT that where you know there are safety related issues where everything needs to be tried out many times. Sometimes you need to actually postpone different changes for half a year when you have this downtime, when you can actually make different how would I say upgrades or updates. But then also obviously cloud, big data, that defines or that really is a key component for Industry 4.0, understandably, but more so also edge computing, which is now raising its head in the OT industry, where you can actually do computation, quite serious computation locally without utilizing cloud, and thus you will get faster results, less latency, and sometimes even better security within your products. And it's of course all backed by machine learning because of autonomy and interconnections. So then when we're going, if we would go into the cybersecurity part, so insights when it comes to cybersecurity, and now consider we're talking about a digitalization of industries that pretty much have an impact of maybe 75% of global GDP, if I'm not mistaken. So obviously cybersecurity is a risk. You have old systems, you have maybe not that much of competence when it comes to facing and protecting and remediating modern cyber threats of the outside world. But at the same time, since a lot of innovation is involved, and innovation draws attention, and innovation is also done on very very fast. It actually results in more people interested in how secure those ICS products and systems are, and more researchers, more people are starting to actually buy them and try them out. Companies are becoming more aware of cybersecurity, and they also are how would I say, trying or evaluating cybersecurity of products, and that results in growth of vulnerabilities found within ICS products. But I believe that most concerning part is that over half of the found products during 2020 are actually found by third-party entities. So where they are found by, if we're talking about technology vendors, they're found by production owners or security researchers. So someone who has not developed those products, and that is a concerning fact. It doesn't mean that there is no cybersecurity whatsoever in these products, but it is a concerning fact that most of the vulnerabilities are found from the outside world. And of course, obviously, this raises concern. But when we go into the when we go forward, it also raises concern on multiple levels. So at one side, you have legislation and regulations that are picking up on this issue, and you have different types of regulations, legislations around critical infrastructure, energy sector being a very important one. Then also, of course, customer behavior, as I mentioned. So customers, as they are becoming more concerned on cybersecurity within their environments, they are actually performing penetration testing exercises, security evaluations of bought products, and they are also more concerned, and they have even more capabilities now to actually showcase that a product is vulnerable and hence demand more security from the vendors. And also when it comes to standards and frameworks, now we have actually something that I would say a common language between the production facility owners and then also the technology manufacturers. So there is, say, minimum requirements for cybersecurity, and there is ways how to achieve those via standards and frameworks, and they're made in a way that both the supplier and the purchaser would understand. So they just need to be utilized. The reason why the 62443 is bolded here is that it's actually becoming the kind of predominant standard when it comes to industrial automation in multiple segments. Obviously, manufacturing, energy, maritime, even maritime has now adopted more and more of the 62443 standard. But what all of this translates to is basically risk-based security. So of course, it's all driven by safety, functional safety, and security in general. But if you look at regulations, they always say that, hey, all that you do needs to be risk-based. You need to understand the risks and act accordingly. Also, many times what's required is the asset and vulnerability management. So you need to understand what's in your environment and you need to be on par with how vulnerable they are and basically patch them one way or another, or create some other remediation activities. When it comes to especially new installations, one thing which is, I would say, the cheapest to do is to create a proper architecture, which actually takes into consideration things like identity management, policies, technical security features, and last but not least, one needs to be prepared to respond to incidents. And this is pretty much, if you look at legislation, you have these four, one way or another, described there. And they're all described in any of the standards and frameworks that you find on the internet. And basically, when it comes to requirements towards a asset owner, or for people who are working in the production facility, you need people that understand cybersecurity and how it can be applied to OT, because it is a slightly different animal than IT. But also it requires organization with a mandate, because change is hard. Based on my own experience, I have seen firsthand how production facilities get breached, how they're remediated, and how their maturity is increasing, and how easy or hard that is. And if I would be working at a production facility, I would definitely shout for having a separate organization. It doesn't have to be a big one, but organization that has mandate to drive cybersecurity on OT level. And of course, technology solutions. So many times it's process related things like incident response, for example, or even security architecture, but it's all supported by technology. And this is something that one needs to understand. What is the technology landscape when it comes to cybersecurity in OT? I can give you a very brief example of maybe some of very concrete things behind these requirements. And I will discuss them in form of risks. So if some of you are looking, or if some of you have more than 3 segments in your network, congratulations, you are above these 80% of environments that I have seen. But the basic setup that at least I've seen is that you have an enterprise network within your OT environments where you have all the cloud connectivity, basic desktop, maybe some historian data available there, business applications running. Then you have supervisory level where basically there are some TIA stations or some engineering happens here. That's where you develop and where you actually monitor your production on site. And then you have the control framework where you basically have the PLCs, HMIs that controls these controllers, and then of course sensors and the actual actuators and physical elements of the network, or sorry, of the production environment. And if we consider risks here, there are, I would say, 2 types of risks. So there's the risks of disruption. So say ransomware cases, which are very normal. They usually come from the outside world, or someone on the supervisory level, they misuse their machines, and then you have then you basically have this sometimes even spreading ransomware across environments, and of course that costs quite a much. But it doesn't necessarily mean that production stops. You have the possibility in some cases to run the production manually, because there are still HMIs, there are the controllers, they're there. But once we actually get to this level, which in previous presentations we were talking about Stuxnet or Triton, which pretty much they are malware that have been designed to deteriorate production. In this case, of course, it's not just costly, it's not just lights out in your production facility or in a city, but there's a series, of course, safety and human safety and environmental risks, health safety and environmental risks involved. But if we think about, if I would have to do a split, I would say that majority of the attacks that happen on an OT environment, they actually happen on these two areas. So it's more ransomware cases, more of your traditional IT issues. But when someone really wants to get you, then that's what you have to face. So if you're in a mission critical or critical entity, considered to be a critical entity, then that is something that you maybe would put more emphasis comparing if you were just a shoe manufacturer, for example. But then we were talking about Industry 4.0, it changes quite a bit. So now we're talking about having connectivity and autonomous decision-making happening very close to the actual control network. And many times these smart devices that are gathering the data, analyzing data, and passing some of the data forward, they might be actually connected directly to the cloud and bypassing nicely all of your firewalls, network segmentation, all the controls that you have in an encrypted manner, which pretty much puts a lot of pressure on cybersecurity for these individual devices. Because behind these devices, you can assume if it's an old environment, there is no security. If someone gets there, they're breached, period. So hence, this is the biggest risk that I see today in Industry 4.0, is that by having these capabilities to produce ton of value, we're actually by default, by design, we are introducing plenty of risks that in many cases are not accounted for when it comes to buying additional new components to your existing heterogeneous environments. So considering the legislation, standards, and also the risks, my recommendations as key security capabilities for modern IT, or sorry, OT, my bad, is first and foremost, know your environment. Understand what type of assets do you have? What type of assets are you going to introduce? What kind of systems are you going to introduce to your environment? And be aware, have a mechanism that would find out how vulnerable those components are. That is your responsibility. This is the cheapest, fastest way to actually remediate things that otherwise can turn bad very quickly. The next part is the incident response. So I would not go and build a ton of walls, but instead I would actually take a budget or part of the budget and consider having capabilities to respond to an incident, be it on the control network, be it on the enterprise network, doesn't matter. There have to be controls and means in place, because once something bad happens, things need to start move fast, and if you're not prepared, it's very hard to actually do the right stuff in a timely manner. But then when introducing new components to your environments, I would actually consider cybersecurity requirements to be added in contracts. And if you're buying individual products, there's requirements that come with standards for secure development lifecycle, product technical security features of products, but also patch management requirements. And then if you're buying complete systems, there's also requirements that are, or a standard that basically describes requirements for having these systems built in a secure way. And also, last but not least, on the security requirements for vendors is the vulnerability notification and patching SLAs. Basically, I would ask my partner to produce or to provide me with information every time they have found or someone has found vulnerability in their products, as well as once it's found, there should be an SLA through which I would need to receive a patch. And then it's up to me how do I implement the patch in my own environment, but at least to have that capability. I know that some cases this patching might take up to 6 months, which means that in the meantime, you need to then make sure to do other compensating security controls and remediations in order to make sure that your environment is not at risk. And last is the risk-based cybersecurity strategy. Once you know your environment, you know what risks are possible, what are their impacts, and if you consider, or if you take this approach of risk-based strategy, you will definitely be able to optimize your cybersecurity investments and protection, detection, and response capabilities. Any questions?